Okay, so I'll do example 4 first. Okay, I'll do example 4 first. I'll just quickly go through the long division. So first of all, I check, do I have all the powers? Power 3, power 2, power 4, and constant. So everything's there. I can just write that down. I don't need to add 0 terms in that. So that's what we have, and we divide by x plus 2. So the only thing different from this one and the previous exercise is what we divide is a linear. Okay, what we divide is a linear. So before, what we divide is quadratic. We can divide cubic, we can divide quartic if you like, but most of the questions will be dividing linears. So I have this linear x plus 2. Okay, x plus 2. So we have, okay, first term divided by the first term. We have x cubed divided by x. We have x squared. X squared times x plus 2 is x cubed plus 2x squared. Okay, so we subtract that. We have minus x squared and minus 14x. So minus x squared divided by x, we have minus x. Boys, minus x squared minus 2x here. And minus 14x minus 2x is plus 2x, which is minus 12x. Get the next thing down, which is minus 24. So minus 12x divided by x, I got negative 12. Negative 12 times x plus 2 is x minus 12x minus 24. And exactly the same. I got a value of 0 here. So this value 0 here tells me is remainder 0. Okay, it's remainder 0. Boys, I really can't think when you're talking. I don't know what I want to say. Okay, so we can see for this one we have no remainders, and then the px I can write in a way like x plus 2 px equals x plus 2 x squared minus x and minus 12. Okay, so I can write px in that way. So this looks really good because that's the factorized form of px. There's no remainder. X plus 2 is divisible by px. Okay, we call it like 4 is divisible by 2. So px is divisible by x plus 2. I get like the quotient, exact quotient, and we have no remainders. So this is also the idea of how we can factorize things. Okay, how we can factorize things. I can keep factorizing this one because there's no remainder. And this is x plus 2. And I can see here that's x minus 4 and x plus 3. Okay, so I can keep factorizing that. So after I find, oh, I realize x plus 2 is the linear factor of x px, then I left with the quotient is a quadratic, and I know how to factorize quadratic. I'll talk about how to factorize quadratic in the next page. But we know how to factorize quadratic now. So this is px has been factorized into 3 linear factors. This is also what we want to do today. Okay, before that, the next part of the question asks you to evaluate p negative 2. Okay, to evaluate p negative 2. Okay, why p negative 2? What's the special thing about p negative 2? If you make what you divide equals to 0, okay, so if you make x plus 2 equals to 0, your x equals to minus 2. Basically, you substitute this value into the equation. Let's see what will happen. So p negative 2 equals to, okay, the original equation is x cubed, so it's minus 2 cubed plus minus 2 squared minus 14 times negative 2 and minus 24. I'm not going to use the factorized form because it's something I work out. Like if I got something wrong in that, I will get the wrong result. But if I use the most original one, I will make sure I can calculate the right value. So this is minus 8 plus 4 plus 28 and minus 24. 28 minus 24. So what we have is minus 4 plus 28. Well, I can't write 8 today. 28 minus 24, and you can see that's a 0. Here, that's a 0. Okay, the special thing we see, we get a 0 as well. I won't make any conclusion here yet. Okay, I'll go to the okay, we have done the long division. What I have done was the question asked us to substitute p negative 2. I worked it out. I will talk about the results later. So now back to the first one. Let's do this long division. This long division is a little bit difficult to deal with because there's a lot of fraction involved. Okay, question, is this a monic linear? No, why not? Okay, there's a coefficient of leading term x, the 2 there, so it's not a monic. Is this a monic linear? What's in the red? Is that a monic linear? Yes, coefficient of leading term x is 1, so that's a monic linear. Okay, we have something to do with that later. Okay, now let's have a think. 3x cubed plus 2x squared minus x minus 2, no missing terms. Okay, no missing terms, which is good. And I have 2x plus 1. Okay. This one divided by that one. We have 3 over 2x squared. That's 3 over 2x squared. So that's 3x cubed plus 3 over 2x squared. Okay, what's 2 minus 3 over 2 equals to? Half. So we have half x squared left. Get the next one, which is minus x. What's half x squared divided by 2x? Quarter x. Okay, half divided by 2 is quarter, x squared divided by x is x. So it's quarter x. Okay, quarter x times with 2x plus 1. We have half x squared plus a quarter x. What's minus x minus a quarter x? Minus x minus a quarter x? Negative 5 over 4x. Minus x minus a quarter. So it's 1 plus a quarter. And get the next one now. So it's minus 2. Okay, the next one we have is this one. What's minus 5 over 4x divided by 2x? Minus 5 over 8. Thank you. Okay, minus 5 over 8 times x is minus 5 over 4x. That's what you get. And then minus 5 over 8. Okay, think about what's minus 2 minus 5 over 8. If you can't really see it, just write it down. It will be that's minus 13 over 8, right? Plus 5 over 8. What's that? Negative 11 over 8. No, that's my remainder. Minus 11 over 8. Have a think. When you divide by a linear, your remainder must be a constant. Your remainder won't involve x. Because if you still have x, you can still divide by the linear. So the remainder must be minus 11 over 8. Okay, remainder must be minus 11 over 8. Okay, so the remainder is this one. Okay, remainder is this one. Now, we also evaluate p minus a half. Again, y minus a half. Why we substitute that? Because we want to make that equals to 0. What we divide, we make what we divide equals to 0, then x equals to minus a half. So that's why we sub minus a half. Same reason why we sub x equals to minus 2 in last question. So p negative a half equals to 3 times minus a half cubed plus 2 times minus half squared minus negative a half and then minus 2. Okay, just sub minus a half. When they ask you to substitute or show that, you must really show the substitution step. You can't just give me the answer. You must show this step. Okay, that's the substitution step. So that's minus 3 over 8. That's half times a half is a quarter. A quarter times 2 is a half. Plus a half minus 2. That's minus 3 over 8. That's a 1. 1 minus 2 is minus 1. and that's minus 11 over 8. Okay, 8 over 8, so it's minus 11 over 8. What you have observed, like from last one, it's not that obvious, but what you have observed here. Okay, we haven't talked about remainder theorem, but this one means when you sub x equals to minus a half, that shows you the remainder. Okay, when you sub x equals to negative half, like it's the same as the remainder. Look at the remainder. We have achieved the remainder. Even though we sub negative a half, we won't know our quotient. We won't know what's here. Okay, we won't know that, but we can see the remainder directly. Same as this one. If you make the divisor equals to 0 and you solve for x, and you sub that x into the original equation, you get the remainder. Well, in this case, we don't have remainder, we get remainder 0. So we can just like, well, if px divided by ax plus b, if px divided by ax plus b, we make ax plus b equals to 0, and then we solve for x. Now we solve for x, and we sub the x you solved out into the original equation. That will give you the remainder. Yeah, that will give you the remainder. Again, can you tell me the advantage of long division and disadvantage of long division? And disadvantage is very long. What's the advantage? Compared to the remainder theorem, compared to what I have done here, and compared to the long division, we both get remainder, right? We both get remainder. But by using this theorem here, like by using this like method here, I can't see quotient. You can't find quotient. I can't see what px equals to. I can only see when this divided by that, what I have for remainder, but I won't see what's the actual quotient. The advantage of long division is even though it's long, but in the end I can see what px equals to. Px equals to the divisor times quotient plus the remainder. I can see like a better look for it. I can see the details in it. Okay, now I'm going to introduce a method which get both advantage, which is shorter, and you can see the whole thing. Okay, you can see the whole thing. Okay, synthetic method. So what you will do is, this is a method, don't ask me why. This is a short version of long division. Don't ask me why, I know how it works, and you just need to remember how it works. And how you read from that table. So let's set up a table. No, I hate that method. That's just too long. No, just don't use that. Just that I teach that in the first year and no one use it, and I feel I'm quite silly of teaching it. Like it's just really long, and sometimes you solve it wrong and you get the wrong answer. So I decide not to use it anymore. Okay, so draw this table. Okay, so this is a cubic, so I draw 5 columns. So cubic, square, linear, and constant. That's 4 items, and then I got 1 column left for what I want to divide. Okay, so in the top one, I write down the coefficient in order from the highest power to the lowest power. So the coefficient is 1, 1, negative 40, and negative 24. Okay, so that's the coefficient of x cubed, x squared, x, and constant. Okay, that's the 4 things. I write down the coefficient. This only works for linear. Okay, only works when you try to divide by linear. If you try to divide by quadratic, it doesn't work. What I want to divide here, what I'm trying to divide in this question, x plus 2. Okay, we're trying to divide by x plus 2. So I'll put minus 2 here. Okay, same reason how we find the remainder, you sub the same value in. So you put negative 2 there. Okay, after we set up this table, next thing is we want to fill out the other 4 boxes. and it will show you amazing result. Okay, how to fill that in? The first box, okay, the first, after you set up that, the first box, copy from the top row. Just copy whatever you have above you, you just copy that number down. If it's a 3, copy 3. If it's a 4, copy 4. So it's a 1 now, so I copy 1. So the first one is not calculating, it's copy from the top line. Okay, second one. After you write down this one, the next one will go through calculation. As soon as you write a new number into this box, you will go to times with the front number and add the next column. So in this calculation is when you write down this one, so you use this one times with the -2 in the front. Okay, this one times with the -2 in the front and add the next column value, which is the 1. I change another color to write it. So what's the calculation result here? -1. So we'll write -1 in this box. As soon as you write -1, this -1 needs to go to times with the -2 in the front. Okay, so always go back to times with that -2. Like this is the key. You can think that's the key. Any number when you write down, you need to go back to times with that. And then plus the next column, so it's the -14. So what we have here? What's that? -12. So we write -12 in this box. As soon as we write -12, okay, so new number has been given into the table, then -12 needs to times with the -2. And then plus the next column, which is -24. What do you get? 0. Okay, magic table. I have filled out everything now. The last one. Okay, the last box always gives you the remainder. This color is too. Okay, the last box always gives you the remainder. So the last thing you fill out is the remainder. And then what we have here, so for the rest of the box, that gives you the quotient. Okay, that gives you the quotient. So the last box is the remainder, except the last box, all the rest of it is the quotient. So what's the quotient? Yeah, the top one, like this one, look at this one. See, this one gives you the cube, this gives you the square, this gives you the x. Now everything reduced 1 power. So that gives you the x squared term, that gives you the x term, and that gives you the constant. Okay. So think about the long division. The px is put here. Well, I'm not going to write it again. X plus 2 is put here. So we threw all the calculations. We get a remainder. So what's our remainder in this case? 0. What's the quotient? Reading this table, what's the quotient? X squared minus x and minus 12. Go back to the top and check with your long division. Is that the same thing? Is that the same result we get? Yeah. So this method works. Yeah, this method works. So I don't need to go long division. Think about how much time you need to spend on this table and how much time you need to do with this long division thing. So it's obviously quicker method by using this table. Linear, quadratic, cubic, anything else doesn't work. And also linear, there's another requirement is the linear when you divide must be a monic linear. So in this case, we divide by x plus 2. This table works well. When you divide something not monic, like let's look at this one. When it's not monic, so 2x plus 1, right? We need to make some adjustments. So let's just still use the same method to create a table. Okay, so it's just a 2-column table. Okay, what's the coefficient I need to put in? So what's Px coefficient? 3, 2, -1, -2. Okay. The value I should put on the second row, first column, what's that? -1/2. You make that equals to 0, and whatever you solve out is -1/2. You put it there. Okay. Yeah. So what's the first one? Just copy, right? Copy from the top row. So 3. After you write the 3, what's the calculation here? Yeah, 3 times -1/2 plus 2. What's the value there? It's -3/2 plus 4/2 half. Okay. After you write half, the next one here will be half go to times with -1/2 and plus -1. What do you get? Half times -1/2 plus 1. -5/4. Okay, -5/4. Minus a quarter minus 1 is -5/4. And the last one is -5/4 times with -1/2 plus -2. Okay, calculate that. What's that? Minus, that's 5/8. What's that? -11/8. Okay, remember the last box is the remainder. And check the remainder. This remainder still works. Even though we didn't divide by monic linear, the remainder always works. Okay, you don't need to do anything with the remainder. Remainder is good. Okay, that's our remainder. That's our remainder. Okay, for the rest of this, it should be the quotient. But compare your actual quotient and that quotient, what you can see. 3/2, 3. A quarter, a half. -5/8 and -5/4. So it's actually doubled. It's the coefficient get doubled. Why the coefficient get doubled? Because we divide the coefficient. There's a coefficient there. Like I want monic linear. I want linear with coefficient 1. But because I have coefficient 2 there, so everything needs to be divided by 2. So everything needs to be divided by 2. Okay, so what we get, we calculate as normal. We calculate as normal, but we put our result divided by 2. Okay, the quotient needs to be divided by 2. So what we will have is, we have the px here. We divide by 2x plus 1. The quotient becomes 3/2x squared plus a cos x minus 5/8. Do you want to come here to see? Remainder is the same. Okay? It doesn't matter we divide by monic linear or like not monic linear, the remainder will still be the same. So we can get this result still, like even though we divide by something. Okay, if we divide something not monic. Okay. This is the method I will use for most of the exercise for this topic. Okay, so set up the tables, find the values from the table. But before that, let's have a look at this. So remainder theorem. So what's remainder theorem? Like I have introduced that already. So if Px is dividing, if Px is divided by linear x plus b, if we make ax plus b equals to 0 and solve for the x, then we sub that into the Px function, I should have the remainder. Okay, I should have the remainder. Should have the remainder. And when your remainder equals to 0, when your remainder equals to 0, like you work out, when sub -2, I got value 0, which means there's no remainder here. And then this is actually a factor. After substitute, you see, oh, do I have a value? Do I have a remainder? Or if I don't have a remainder, what I'm trying to divide must be the factor. Okay, must be the factor. So this is the remainder theorem and the factor theorem. Okay. Okay, so find the remainder when px equals to that. Okay, I can do two different things. First of all, if I'm just interested in the remainder, what you would do? So what do you need to substitute in this case? Xp, so that's p of x is p of x, p of 2, right? So x minus 2 equals to 0, x equals to 2. So I will sub p2. I will sub 2 into p, so we have p2. So p2 equals to 2 to the power 3 minus 3, 2 to the power 2 plus 2 times 2 plus 6. So that's 8 minus 12 plus 4 plus 6. And that's a 6. Well, you know what I'm thinking about is how useful is remainder theorem? Like the factor theorem is pretty helpful. Like we use factor theorem later. But when you just want to find something's remainder, what's the point of it? Like what do you need? Why do you need remainder? Well, if remainder is 0, good. I know that's a factor. That's what I need. But when it's just give you a 6, doesn't really help anything. So actually, and also when you do the substitution calculation, it still takes a long time to do it. What I want to do is just this table can show you remainder as well. Okay, so I just want you to practice the table again. So what I substitute is a 2 here. Well, when they ask you to use remainder theorem, you must use the left-hand side method. When they ask you to use remainder theorem, you must do the left-hand side method. But if without asking anything, just want you to divide by that, what's the result? You can just use the table. So set up the table 1 minus 3, 2, and 6. Okay, first of all, you need to set up your coefficient from the highest power to the lowest power. And say in the middle, if you don't have one term, you don't have x squared term, you need to put 0 there. Okay, you need to put 0 there. So same as long division, you need to put 0 there. I will show you examples later. Now, what we have is copy the first one, we get 1. 1 times 2 gives you 2. 2 plus minus 3, what's that? 2 plus minus 3? 2 plus negative 3. Negative 1. Negative 1 times 2 plus 2. Negative 1 times 2. Negative 2 plus 2, 0. 0 times 2 is 0. Plus 6, I still got 6. So I can see the remainder. The remainder is still 6. Okay, the remainder is still 6. And also I can give the result of px as x minus 2 times x squared minus x plus 0 and then plus 6. Okay, I can give a better look of it. Okay, so that's the x squared term, that's x term, and there's no constant term. So the coefficient of these terms. Okay, if you want to find remainder for this one, what do you do? This question is actually an idea of factorize. Yeah, if you want to find remainder, what do you do? Sub what? Negative 1. X plus 1 equals to 0. You sub negative 1. So when you sub negative 1, okay. Why I got remainder 0, what that means? Why I got remainder 0, what that means? There's no remainder. a little bit further, what you can say about x plus 1 is a factor of px. Okay, so px is divisible by x plus 1 and it's a factor. Now, like the interesting comes, if x plus 1 is the factor, oh sorry, plus 6, and then that equals to 0. I think my pen doesn't work very well. I write it. So it's plus 6, and then minus 1 minus 4 minus 1 plus 6 equals to 0. Okay, so px, and no one of the factor is x plus 1. So what's the other stuff? Like what else left in this box? Like there's no remainder. The remainder is plus 0. But like why I know this is a factor? I'm interested in what's the quotient. When px divided by x plus 1, what do I have? Okay, in that open bracket, like the empty bracket. Well, if you don't know synthetic method, you need to do long division. Just use px to divide by x plus 1 and find the quotient. But because I know how to do synthetic, I can quickly work out the value. This table is really good for factorizing. So we have 1, minus 4, 1, and 6. And I'll start multiplying it. So the first one is copied from the both. I have 1. 1 times minus 1 is minus 1. Minus 1 minus 4 is minus 5. Minus 5 times minus 1, which is 5. 5 plus 1, which is 6. 6 times minus 1 is minus 6. Minus 6 plus 6, that's a 0. So I can see the remainder is actually 0. And my quotient is this one. So in this bracket, I can write x squared minus 5x and plus 6. Because I know I can use this table to work out what's the quotient y divided by x plus 1. And after I have a quadratic, I know how to factorize the quadratic. That's x minus 2 and x minus 3. It will give me minus 5x. Okay, so the remainder term is really helpful because when you stop the value in, you work out that's a 0. You know that's a factor. And when you have the factor, you can use the table to work out what's the quotient. And from the quotient, you can further factorize from the quotient. Okay, I'm not going to continue with the next one. I'll start relations on B and C. We kind of finished a little bit of C. Okay. So what I want you to do now is to do those 4 questions. It's nothing new. Okay, it's quadratic. It's quadratic factorized. I want you to use the rest of the time to revise on quadratic factorized because when you factorize cubic, you get a linear out. And you will left with a quadratic, and then you need to factorize the quadratic. So you need to know how to factorize quadratic. So this is like a couple of examples to show you how to factorize quadratic. Read through that and then work that out. And that's what you need to do for the next 10 minutes. And you can do some exercise. Yeah, make sure you revise on the table. Monday will directly use the table to do factorize. It's magic, it's fun, but you need to know how to use it.